So welcome back, everybody, to day 2 of our Wavefront training. Today we're going to be focusing on the query language itself. We did do a bit of a preview of that yesterday, and I'll recap that as we get started today. But we'll be looking a lot more at the various functions and use cases that you can do with the query language in today's session. I did want to just check any questions from yesterday that anyone has. I did see that some people tried the exercise. Actually looked like there unfortunately might have been a little bit of a glitch in our integration currently, which we will fix, but it seemed like people were able to get through it despite the glitches. And in fact, not that it was planned that way, but the fact that you have a glitch actually makes you need to debug it and understand exactly how all the pieces are fitting together. But it wasn't supposed to be that way. It's supposed to be just completely turnkey. If there are no questions, there was one thing that I wanted to show from yesterday. We discussed this, but I realized we didn't actually show it directly, the integrations page. And there were some questions yesterday about the AWS integration. And I looked at how you have it configured after the session yesterday and just wanted to point out a few things here. So this is the integrations page. In general, you're going to see literally hundreds of different things that you can connect to out of the box.
I don't think you can see your screen, Connor.
Oh, sorry about that. Here we go. Hopefully it's sharing now.
It is.
Okay. Yes, so I was scrolling through this page, oblivious to the fact that you weren't seeing it. There's lots of integrations here. Per yesterday's discussion, many of these integrations are based around Telegraph, although not all of them. Of course, an example that is not Telegraph-based is AWS itself. These various cloud provider ones are completely within Wavefront, where you just point and click, connect to the cloud provider. It pulls the metrics for you. Wavefront pulls the metrics for you. You don't need to install anything locally. All of the integrations do follow a common pattern, whether they're a cloud one or a Telegraph one or anything else, with an overview tab, setup instructions, a preview of the metrics that are available with that integration and that are visible from it, and links to dashboards that integration comes with. In the case of AWS, I just wanted to point out, from an abundance of caution, I'm not going to click your actual one here, because it will show the role ARN that's being used. But I'll add a new one so you can see the settings. There are a few settings available on the configuration. You may already be aware of them, but I noticed that except in the staging integration, you hadn't used any of them, so I just thought I'd point them out. It's possible from here, if you wished to filter out the data, basically. Filter EBS or EC2 volumes that you don't care about. Like maybe you have a role that defines whether something is production or development. You might want to potentially ignore the development ones or something like that. You can whitelist which metrics we actually retrieve. So by default, it's going to grab everything in CloudWatch. If you ultimately look at all the CloudWatch data, then that's great. You get it all by default. But if you only look at a certain subset of AWS services, or indeed a certain subset of metrics within AWS services, this is a way that you can filter down to just the data that you need, and thereby reduce the number of CloudWatch API calls that Wavefront's making to pull the data out. This whitelist, actually all of these whitelists are regular expressions. So it can be a little fiddly to set it up, but nice and flexible in terms of what you're specifying. This point tag whitelist actually relates pretty closely to a discussion from yesterday around how Cloud Health is using source tags to populate common tags on your AWS and other cloud provider sources so that all metrics reporting that data have visibility of those source tags. It is possible to get point tags of the same thing. So Wavefront can extract the tags from AWS, but it is putting them as point tags on the AWS CloudWatch data itself. So it goes back to the same discussion from yesterday that even though this feature would put the tags on the AWS data, those same tags would not be visible on other data that you're ingesting separately about that source. For instance, data from a Datadog agent. But by using source tags in the way you're working around that issue. The other thing you can do here is tweak the interval at which we're polling for metrics. It defaults to 5 minutes. We default this way because a lot of the metrics in CloudWatch themselves have a 5-minute refresh. But certain metrics you can get every 1 minute. So if you wanted to, you could set up an integration specific to a certain whitelist, the specific metrics that you want more frequently, and you could set that one to, say, a 1 minute refresh rate instead of 5. And similarly, if you wanted to reduce the amount of CloudWatch API calls that we're making, and you had metrics for which you don't really need them in a timely way, you could increase this number as well. But hopefully that's helpful. I just wanted to point that out in case there's any useful features there for you. So this is a slide from yesterday, and just recapping the introduction to the query language. What we looked at yesterday was this green part of the query, which I compared to something like a SQL select statement. Obviously, it's not actually SQL, but it's a similar concept in terms of defining which data you want to retrieve and how you want to filter it. What we're going to look at today is the various functions that you can apply on top of your data to manipulate it and choose how you want to visualize it. One thing that you can see already just from the example is you can definitely chain these functions together. It's not limited to, say, you select something and you apply one and only one function on top of it. Many times you will only need one function, but if you need to chain things together, like in this case, it's grabbing all of the data that matches this query, averaging it all together, and then looking for a 10-minute moving median of that aggregated data. So very easy to combine expressions to do lots and lots of different use cases. I'm going to go back into the queries itself and just reiterate a few of the things I showed yesterday and then build on that a little bit. I also wanted to point out here a common gotcha that actually came up in the questions yesterday in the Cloud Health channel as one of the users was playing with the system and working on a dashboard. So per yesterday, you can use the query editor to point and click, define queries and filter data and apply functions on top of the data. During this training, I am mostly going to be using the query builder, or the query editor, I should say, where I'll be typing queries directly. The building block for that, again, is TS, which stands for time series. I'm forgetting my sample here. So something that I didn't point out yesterday, but is pretty useful, is any of these queries can be named and then referenced from other queries. So I might name this one, say, data, Even the A that was there previously would have worked just fine. But I can then add other queries and refer to the data. So if, kind of jumping ahead to a aggregation example, but if I wanted to sum up or add up all of that data, I can do so like this. The buttons on the right-hand side allow you to toggle whether a query is on or off. So I can turn off the previous one that was showing all the individual series, and now I'm summing it up. In this case, it's a very simple example. So even if I just had one query with sum around here, it would be clear what it was doing. But I find this to be pretty helpful if you have complex queries that are doing a lot of manipulations on the data. If you break them out like this, it can make it really clear what's going on. And you can even, if you wish to, add descriptions on the query lines to, if you're building a dashboard or a chart that you're expecting a lot of other people to use and consume, you could put descriptions on there to explain what it's doing, so that if an interested user drills into it, they can understand more easily. The little gotcha that came up yesterday that I wanted to point out is this. By convention, Wavefront, in our documentation and in our examples, we usually put a comma between the metric name and then any filters that you want to put on the data. So here, for example, I'm looking at this metric, request latency, and I'm filtering it down to the app1 source. It is also our convention in the doc that for other filters that we add, we explicitly write things like either and or not to say exactly what it's trying to do. It is legal to put commas instead, but it can often do unexpected things. Or if you know what it's doing, it's not unexpected, but it can be an initial gotcha for a user. The comma means and when it is between two different things. So here I have a metric and I have a source. The comma between those is equivalent to and. So if I run this query again, I should get the same results. Oh, it's not liking that actually. But the comma between like things, like here I have two sources, so these are two of the same concept, it becomes an or. So that it's often the case that users will put commas, they'll think that it means and everywhere, but actually if it's between two similar things, it will be an or. Therefore, we suggest, just to keep it simple, whenever you're adding filters in your queries, just use and or explicitly. It'll be just much more obvious what it's doing. Any questions about that?
Can I group series of filters together as units? So say source app equals 1 or source app equals 2 and something else? Yes.
So the grouping, Wavefront query language is not a Lisp exactly, but it does certainly have a lot of parentheses like a Lisp would. So the grouping would be done like this. So I've put the parens around that, and it's now a group, and I can do and something else. I don't even know if this will end up with any data or not, but let's see. It did in this case. One thing, a question that does come up a lot is around stuff like regular expressions for wildcards. That's not currently supported. So you can put asterisks to match anything, but this is more like a shell glob. It'll just expand to match all. There is not regular expression support. There is a feature request to do that. It's a common request. I expect that we will not add full regex support, but it is quite possible that we could add a subset that would be beneficial. That said, although it's more long-winded, you normally can, with with the right combination of and, or, and not, and grouping things like you see here, you normally can express whatever the precise filter you need to get exactly the data you want. So here are the functions that we're going to be looking at today, or the kind of categories of functions. We are going to focus, I'm not sure how clear the PowerPoint makes that highlighting, but we're going to focus on the first 5 of these. Several of the other categories will kind of appear in the examples that we'll look at, and we'll discuss them naturally as they come up. I would ask if I have a dashboard with examples of these that I'm going to look through. I also have some other, what I hope are useful use cases that I've pulled together that are not on the dashboard. But if you have actual real use cases from your own things that you want to accomplish with Wavefront, please feel free to call them out and we can look at those directly. I'm happy to make this as interactive as you wish. I would say if you're doing some further reading afterwards, probably the functions that we're not covering today, but that are most common or most interesting to look at would be missing data functions. Things like default, last. This allows you to specify if the data stops reporting, what do I want to do about that? Like it's often the case when you're configuring systems to send metrics to something like Wavefront that you might say, do not report a new value unless the value is different from what it was before. If you know that your data is behaving that way, then there's a function in Wavefront called last, which would essentially persist the previously reported point forward until a new data point appears. So that allows you to convert the gappy data that's not being sent on a regular interval because it's not changing into what appears like continuously reported data in Wavefront. Similarly, it might be the case that a system won't report values like an error count unless it is above 0. So there's a function called default, which would let you say things like, if the data is not there, assume it to be 0, because I know that the system's not going to send it to Wavefront if the value is 0, but I can still fill it in. The metadata functions can be pretty handy. These are things that allow you to rename metrics, rename sources, add tags on the data synthetically if you don't have them. Like say your source name, which I see in Cloudtail's case, you have some pretty consistently named sources, like things that begin with production dash and so on. If you did not have a tag for environment equals production, you could extract the production string from the source name, treat it as a tag. And also one that would be fun to look at is the predictive functions. These are relatively new. You're going to see in the query language today a lot of capability for analyzing data, manipulating it. You can do a lot of statistical techniques on top of the data. But as of recently, we've got automated AI capabilities in the product to just look for anomalies without you having to do anything special with the query language. I would say it's a pretty new feature. It's going to get improved and iterated on over time, but it's worth playing around with. You'll see the function in the documentation called anomalous for doing that. I'm going to navigate here to a dashboard showing the categories of function that we're going to look at that has examples. If you'd like to follow along, please feel free to do so. I'm navigating to it in the Cloud Health instance, but the same thing is set up on the VMware sandbox. So if you don't have access to the Cloud Health instance, that's okay, you can still reach this. I'm going into dashboards and then all dashboards. And in there, there is a tag path which we set up called wf.training. If I click training, there's a few dashboards that are highlighted here, or that come with that tag. The one we're going to be spending a lot of time with today is this Wavefront training dashboard. Something else I'll point out though, which I think is a great help when learning the language. This is not something that we built for the training specifically. This is an out-of-the-box dashboard that comes with the product, but it is essentially an interactive reference of the entire query language, or at least close to the entire query language. So you can work your way through this and see examples with real data, or at least with real sample data, of all of the various functions and things that you can do. This is pretty complete and pretty helpful. If you prefer more like regular doc, the other good thing that I would suggest is looking at the language reference. This is just part of the documentation, so it is on docs.wavefront.com like the rest. But because this one is so important, it's called out as its own thing under the gear dropdown. I have often suggested to people, I guess it depends a little bit on your learning style, but I've often suggested it's worth just giving this thing a quick read through as you're starting to learn and starting to use Wavefront. Not in the sense of trying to memorize it all, but just to get a sense of all the different things that are there. And then as you're trying to do some real work with the product, you might have your memory jogged, like, oh, I remember there was some function that might help in this case, and you can go back and look at more details. This is the dashboard we'll be looking at with a lot of examples of the different categories of function. And we're going to start with aggregations. I also actually have a little example of this that is coming from your real data. Now, the concept of aggregations is pretty straightforward. And I think I tied this part of the query language back to something like a SQL select. Aggregations, I think a lot of users recognize them as similar names from things like Excel. So you want to do things like sum up or add up all the data. You want to get the average of all the data, the max value, the min value. You can even do percentiles. These are all examples of aggregation functions in Wavefront. The concept of them is basically taking multiple input series. Like here, there are 3 production Elasticsearch things, all reporting their JVM heap usage. And I want to combine these together in some way, like sum them up, for instance. And so aggregations are all about taking multiple input series and collapsing those down into a lesser number of series. If I look at this case, I see 13 gigs approximately, 7 gigs approximately, 2 gigs approximately. So if I sum these up, I would expect to get something like 22 gigs. And I'll do that same query line variable thing that I showed you earlier. And sure enough, I get the answer that I was expecting, something around 22 gigs. So this seems to just work. But I'm going to show you and look a little bit under the covers of what exactly is happening here. And it ties to the definition here of standard and raw aggregations. So this is a screenshot of that same data that we were just looking at. And you can see that when I zoom into it and I put it into a point plot, the data here is not actually reporting aligned with one another. It looks like for each of the time series, they are reporting like every 15 seconds, that looks like. But they're not reporting like aligned, like on the minute, then 15 seconds passed, then 30 seconds passed. So there's a little bit of jitter that way. And so the question is, what should an aggregation like sum do with data like this? Because if I'm going to add these values up, there are sort of gaps in the data where I don't have values for each of the series, as you can see with these question marks. I'll actually build this out. What the standard aggregation functions will do, and you saw it in the fact that we got the correct answer of 22 gigs, is that they will interpolate values for any missing data points. So when you do a function like sum or max or average, you will get an output data point at every time interval where there was a point in the original data. So you're going to get 3 points here for each point that there was a real physical data value. And the function will interpolate any missing values across the series. And you get the right answer. And it works pretty nicely. And so you might ask the question, why even have raw aggregations? And the difference in how you run them is all aggregation functions in Wavefront, whether it be sum, max, percentile, any of them, they all have a corresponding version with the same name, but with raw in front of it. And the difference is that raw does not do that interpolation. You see how the answer for raw is actually jumping up and down all over the place because it's only reporting the result for series that actually existed at that point in time. Generally speaking, and especially if for new users, I would suggest just use the standard versions. Most of the time they do the right thing, and the goal of them is just to do the right thing without you having to think about it. The place where they can give you a strange answer, and really the reason why the raw versions exist, is say that we want to have a dashboard or an alert that sums these up, and it maybe alerts if they are using, in this case, probably the real world alert would be greater than some amount of memory. But let's say we want to know that it's always using at least X. So we want to know it's always using at least 15 gigs of memory. If one of these systems crashes, then obviously the sum will reduce because instead of adding up 3 series, we're only adding up 2. And as far as an alert goes, that'll work just fine. The system has crashed. The sum number will be lower than it was before. It may meet this threshold, and therefore the alert will fire. Everything's good. Where it can give a strange result, though, is if you're looking at this on a dashboard. You have these 3 series here. One of them crashes for some period of time. During the time period when it is actually stopped, the sum result shows you the correct answer, which is a small number. But then when the crashed system comes back, like it gets restarted, the problem gets fixed, then suddenly there is both an old data point and a new data point, and the system can interpolate the values between those two, and suddenly the sum that you're looking at pops back up to the original answer, as if the system had never crashed. So I hope that made sense. Basically, sum is trying to do the right thing, but it can, when you're looking at dashboards, mask the fact that some system actually stopped reporting for some period of time because it's interpolating the values between the time when it stopped and the time when it came back. Any questions about that, or did that make sense? I have a little example here of aggregation using the raw version, and from a question that Scott from the Cloud Health team had asked recently. Remember, we were discussing about how to look at the total number of sources that are reporting and which sources are reporting. And we did that using this metric counter. I realized after the fact, or kind of during that discussion, a lot of the sources that you have are coming from the AWS integration, and they may have strange names. Like the AWS integration is treating like an EBS volume and its ID as a source. So that might be blowing up the number to something higher than what you expect. But I did notice that you had pretty consistent names for your kind of quote unquote real sources, like things beginning with production. So what this query is doing is it is filtering the metric counter down to those that begin with production. It is then aligning them, which is a function we'll see shortly, and then using the raw count of those. And it gives something like 5,000. I don't know if that's closer to the real value that you were expecting.
Yep, it certainly is.
This align, by the way, is, and the reason why I'm showing this example here, when you're using the raw versions of the aggregations, you almost always will be aligning the data beforehand. What align does is snap all the data points to the same interval. Therefore, whenever the raw aggregation is doing its thing, it's not missing any data points because they're all snapped to the same time anyway. I wonder if I can show that here actually on the original example we were looking at. So you see how I've switched this to a point plot, so I can see the individual points, and we can see how they are not aligned. If I then align these to say 15 seconds, because I think it is 15-second reported data, we can see now that they're well aligned there. And now if I take the raw sum of these, we get the big number that we're hoping for. Actually, I'll turn off the old version. So now this is the way that you generally use raw functions. You align the data so that you're snapping it all to the interval that you want, and you're summing it all up. And this, as well as the kind of weird masking of a system that disappeared for a short period of time that the standard aggregations can give you. This is the other reason to use raw functions like this, is they can have a performance benefit. In this case, you're only summing up 3 time series. That's very fast. But if you imagine that you're trying to aggregate across thousands of time series where they are all not well aligned with each other, the system's having to do thousands and thousands of interpolations of data between all of those reporting systems, which adds up to the complexity of running that query. Whereas if you just simply align them all ahead of time and then use the raw version, it's going to perform a little better. You might see, in fact, I think we can probably get it to show up here. You might see a warning message sometimes to that effect. So I've switched from the raw version of this function to just the standard aggregation. Count, by the way, is simply counting up the number of lines that it sees. It's an aggregation function that is just collapsing the data down from lines to the number of lines. And you see that it gave me this warning message saying, this data has been pre-aligned making it equivalent to a line of 60 seconds. This is done for that same performance benefit. If the system's trying to add up, I think it may be either more than 100 or more than 1,000 lines, or aggregate across more than that many lines, it'll automatically align it under the covers just to help performance so that it doesn't have to interpolate so many data points. If you don't want it to do that, like say you know that your data reports every 15 seconds, like it was in the previous example, then it's not a problem. And if you really wanted to use the 15-second data, you just align to 15 seconds yourself, and then the system will not touch that. Switched over to the dashboard. This is the dashboard that everyone has access to if you want to try these things for yourself. Through the various examples that we've looked at, we have looked at a lot of these already. So there's maybe just one other thing that I want to point out here. We are looking here at some AWS data that's getting reported. There's a bunch of tags on the data, including region, account alias, and things like that. If you run a aggregation, as we've already seen actually, if you run an aggregation without any argument at the end, it'll take all the input lines and collapse them down into one. But all aggregation functions allow you to optionally define how you want to group by. So you put a comma afterwards, and then you put the tag that you want to group by. So this changes it from grabbing all the data and collapsing it into a single average to the average grouped by region. You can group by multiple as well. So there was also an account alias tag on this data. So now the average is grouped by both region and account alias. And to be honest, I haven't seen a lot of examples where people are grouping by more than 2 or 3 tags, but there isn't any particular limit. Like whatever you need to do, you can group by.
Am I able to do this with source tags?
Yes. Actually, there's a funny thing about source tags, though. Let's see. This data probably does have some tags on it. The way to do it with source tags is like this. So I'll actually mention, aside from individual named tags, like we showed before, region, account alias, and so on, you can specify source tags. You can specify tags. This will do it by all the point tag values, which probably actually is pretty much the same data as the original before the aggregation happened. You can aggregate by sources themselves, so not tags that have been added to the sources, but the actual sources. And you can also aggregate by metrics. Now, in this case, there is only one metric name anyway, but say there was a wildcard in the metric name, then that'll group by the matching metric names. And so you see here the metric names that match the wildcard were maximum, average, sum, sample count, etc. Going back to that source tag example, the one thing to remember when you're grouping by source tags is that you have to have asked for the tag in your query to make it appear. I think there probably are some tags on this data. So by saying tag equals star, this should pull them out. Although I'm not 100% sure that there are tags on this, but I think there may be. Maybe not, or at least the query is taking a long time to run. But hopefully you get the idea. Like put the tag that you're trying to match for, or tags that you're trying to match for in your query, like separating them like this. Oh, here it comes. There are tags. It just took a while. Okay, I see. It took a while because it's finding loads of tags on this data. You specify the ones that you're trying to match to and then group by them, and it'll work. That makes sense?
Yep.
So let me see if there's anything else here that we have not covered regarding how aggregations work. I think we've covered all of this. Again, just to reiterate, the whole concept of what we call aggregation functions is I've got multiple lines and I am trying to collapse those lines down into fewer. Sometimes it's down into one line if you don't have any group by, but in any case, even if you have a group by, the idea is you're taking a bunch of input lines, aggregating them together, and having lesser lines out. They are, in my mind, very similar to moving time functions in that both aggregations and moving time functions are aggregations. The difference is that moving time functions are aggregating each individual line or each individual time series over time. So rather than you sending in a bunch of lines and collapsing that down into a lesser number of lines, whenever you use any of these moving functions, you're inputting, say, 10 lines, you're going to get 10 lines out. But in this case, each individual line is going to be aggregated itself over the time period that you specified. Let's look at some examples. And actually, hopefully my mouse is in at a reasonable pace on the web meeting, but I almost think of them as like aggregation functions are about aggregating vertically across time series, and then moving functions are about aggregating individual series horizontally across time in this direction. There are pretty much corollaries for every aggregation. There's pretty much a moving version of that. So average becomes M average, sum becomes M sum, max becomes M max, percentile becomes M percentile, and so on and so forth. All moving functions, I'll actually take this down so it's just one of them. All moving functions take as their first parameter the time window over which you want to do this aggregation. You're going to see several functions in Wavefront, even besides the moving ones, that take time windows like this, and they all work the same way. They take an integer followed by a letter that denotes the time period. You can do S for seconds, M for minutes, H for hours, D for days, W for weeks. There is no year, so if you wanted to do something like a year, that would be 52W. The other one that you can do, which is kind of a special case but good to know, is VW here stands for view window. So view window is referring to the time period of the chart that we're looking at. And we're currently looking at a 2-hour window from Jan 1st or from Jan 15th, sorry, this time period. One VW is saying one view window. So what I'm seeing at the right-hand side of the chart here is what is the maximum value for all of these input time series over the history of this 2-hour window that we're looking at. Hopefully that makes sense. One thing I'll point out is this style or this time parameter of 1 VW is really great in dashboards. I find it really helpful to be able to set up a dashboard that will just dynamically adjust its answers based on the time window that the user is specifying that they want to see the data over. But I would not use this in alerts. We'll be looking at alerting more on Friday, but just bear in mind, this is for dashboarding, not for alerting. And we'll look at alerts more detail later. Moving percentile, by the way, is a bit of a special case. All of the other moving functions take simply the time window over which to do the aggregation and then the data over which to do the aggregation. The moving percentile is an exception where you're specifying the percentile that you want. And in this case, it happens to be 99.23. Hopefully that all makes sense. Let's again check and see if there's anything that we didn't cover. Oh yeah, I suppose something that I didn't quite make clear, but is worth knowing. The clue is in the name, but these truly are like sliding windows. So any of these moving functions at any point in time along the time axis, what I'm seeing is what was the 99.23 percentile for that series for the 6 hours in this case prior to this data point. And it just continues to move along in that fashion. If you zoom in on the data from a moving function, you'll see that it is actually continuous under the covers. So even if you were reporting data values every minute, say, if you then do a moving function over that data and you zoom into it, you will see that you actually have values at every single second for that moving function. And at every second, it's going to be the aggregation over the time period prior to that second. So if that makes sense. And that's why when you're doing something like the max over the current view, the value that's of interest is the value at the right-hand side. The value in the middle here is the max value at this point in time, and then half the chart again to the left-hand side of the current window we're looking at. Because of that, I personally do this a lot. Whenever I'm doing things like one VW, I usually mean that I literally want the value at the right-hand side. Few ways that you can handle that. One is just look at the data in a table, because the table view is going to show you the value at the right-hand side of the chart anyway. It's kind of what it's there for. But the other way is, even if I'm in a line chart, I can say, using the at function, that what I'm interested in is the value at the end of the chart that I'm currently looking at. So now, instead of seeing these values changing over time as the moving window slides along, I'm just seeing the whole way through the chart what is the value, the maximum value for each series at the right-hand side of the chart here. All right, so moving on to filtering functions. These are functions for kind of reducing the amount of data that you have on a chart. We've already seen actually align. Like align is filtering in the sense that it's taking a bunch of data that might be reported every second, every 15 seconds, and you could use that to align the data all to a minute or an hour or a day. The time window that align takes is the same as the moving functions, where you can say seconds or minutes or days or whatever you need. That function is what this bullet is referring to. Like if you have a bunch of data that is being reported like every second, say, and you're trying to aggregate that data over weeks or months, you could align the data to like a day and then aggregate it, that will reduce the complexity of the calculation that Wavefront has to do. Rather than calculating that data for every single second, it can have an easier query to do over the daily aligned buckets. High pass, I'll show examples of high pass and low pass. These are kind of for throwing away the data values that you don't want to see. And top K and bottom K, very useful for just looking at what's the highest values, what's the lowest values. Let's look at some examples of these. We'll go back to the dashboard. I'll have to switch this to the line plot. So here we're looking at, again, it looks like a CloudWatch metric, something JVM related. High pass and low pass are basically the inverse of one another. So if I look at the original data again, I have a bunch of values around 70. Some of these time series are poking up over 80 from time to time. And so if I say high pass of 75, this is going to only show data that is 75 or greater or above 75. An interesting thing to note about this is that it can result in sort of gappy data. And if you remember to what we were talking about, aggregation functions, where data is gappy, that's where the aggregation function will interpolate values for the missing data or for the gaps. So be aware of that when you're using something like high pass, you may introduce gaps in your data like this, and that may then lead to interpolation when you're aggregating across it. Low pass, same thing, only the other direction. So these are the ones that are lower than 25. I actually see so the top K example here is showing what are the highest 20 of the series, and it's basing what is highest by which ones had the max value over 2 chart windows. So again, we're looking at a 2-hour chart window. So the result of this query is what were the highest 20 of these series over the past 4 hours. If you don't specify these arguments, then the way that top K and bottom K, so bottom K does the same thing, just in reverse, showing the lowest ones. It's just going to look at what, at the right-hand side of the chart that I'm looking at, what are the highest 20 right now. So that's obviously a very simple query, and it often is what you want. But the optional arguments here are allowing you to say, well, just because it's the highest one right now, it might not actually be the highest or the most interesting one historically. So I want to see what are the highest, in this case, it was doing the view window case, but I can say in the past hour or whatever makes sense for my use case. Make sense? Because top K has these this ability to specify how you want to determine what top is, you may never need to use the kind of underlying function here. But I'll show it because I think it's kind of interesting to see how this actually works. If I pull up some of this sample data again that we've been looking at, so I'm just graphing the data. Let me actually get it down to just the production stuff. Top K is syntactic sugar wrapped around a function called top. If I run, and again, most of the time, I think you're going to use top K. It's very simple to use. It does what you want. But there are a few use cases where top can do pretty interesting stuff. So the way that top works is it takes all those input time series and it turns them into Booleans. You see how I said top 2, and I now have 2 of the time series which have a value of 1. These are the highest 2. And then I have a whole bunch, like the rest of the series, that have a value of 0. These are the ones that were not top 2. One of the categories of functions that we may not look at that much, but what is in the list is comparisons. And so there is and they're actually really useful and really cool. There is a if function in Wavefront. I haven't seen a lot of time series systems that have an if and let you really do conditional logic in the expressions that you're writing. But what I can do here is I say, if it is in the top 2, and actually let me do my usual name this one data. I'm going to say, if I'm in the top 2 of the data, then show me the data. So if has it's same as if in any language, really. It has a condition. So this is the thing that is reporting either false or true values. It has a then, and it has an optional else. So in this case, I didn't supply the else, but if I put in an else of, say, minus 2k, then what this is showing me is most of the series are minus 2k because they had false values. The original series has the original data because it had true values. In this case, what I really want is I don't want the else. I just want the else to be nothing, no data. This is what top K is doing. The one place where you may want to use this, and where I have used this and found it to be useful, that you cannot do with top K, is say I want to do something like, for the ones that have the highest request latency, I actually want to see let's see, what else is there? I want to see the total number of requests that those are processing. So I want to see the top ones, but I don't want to see the latency. I want to see the requests. So this is now, all right, and I can even change this to say things like, for the ones that had the highest latency in the past 2 hours, what number of requests are they actually processing? And there's even a function in Wavefront to collect multiple different data together. So I could even say, if I wanted, I want to see, for the ones that had the highest latency in the last 2 hours, I want to see how many they're processing. And I do want to see the actual latency as well. And now I've got all that data on one chart. So if is not a function that you probably use as a brand new user, but it can be very powerful and allow you to express really interesting and useful use cases as you get into the product. Okay. Operators are all about combining data together. We actually saw this, I think, in one example. I used a Boolean comparison. And indeed, the top thing that I just showed you kind of turns data into Booleans. Comparisons are the way, or essentially the thing that drives alerting. So you graph data, you manipulate data to capture the thing that you want to capture, and then you say, I want to know if this thing is greater than or less than or equal to or not equal to. And all of those operators will turn the input data into Booleans that can then drive alerting. Or, as you just saw, those same Booleans can also drive the if logic in Wavefront. Arithmetic operators, pretty self-explanatory, hopefully, for just doing math on the data and combining time series together to form new time series. And we will see in the examples here, we're going to see how these operators do depend on being able to match the series on either side. Like if you think, if I have one query that has CPU data in it, and I add that to another query that has memory data in it, the system has to figure out for which lines on the CPU data match up to which other lines on the memory data, so that it adds up the right thing. Going back to the dashboard, here are the examples that we've set up for you of how these operators work. And the first example is around essentially kind of calculating a new metric on the fly using just math operators. In the sample data, we have got two metrics for disk space. We have disk space total, and we can see that across all these reporting hosts, they're all reporting the same total disk, 500 gigs. We're also reporting how much disk space has been used. And that's this one is a variable number. We're not actually reporting as a metric free disk space. Now, maybe ideally you just start reporting that metric, or use an agent that reports that metric. But because Wavefront allows you to manipulate this time series data and do arbitrary math on top of it, and you may find yourself in real situations like this where you don't have the metric that you want, but you can calculate it from the metrics that you do have. So if I want to calculate free disk space, it's pretty simple. I just take the total disk space and I subtract it from the used disk space. Obviously, per what I've mentioned, the system is having to match the correct things on either side of this operation. It has to subtract the correct used space from one thing from the correct total from the other, so that the answers we're getting here are accurate. Generally, the system just does that for you. This is another case where it's a bit like aggregation functions. Generally, using the standard aggregation does the right thing. I would use it as my first go-to. But if I get stuck or I'm not getting the results that I'm looking for, I can dig into exactly what's happening and look at the details of how the series are being matched. But generally, it's just going to look for matching metric names, matching sources, matching point tag keys and values on either side, and match the data up as best it can. And indeed, in this case, it just works. In this case, you'll see an interesting thing. Actually, I'm going to change this example slightly. I'm going to show you the real intent of this. There is a special case for matching, which is if either side of the operator has only a single series, like say I wanted to multiply the disk space used for everything by 10, and therefore 10 is a single series, then by default, that side of the series that has only a single value is going to match up to all of the input series on the other side. So it's kind of no, in fact, the description says here, no series matching is occurring. If you don't want that to happen, if you want to be strict about it, you wrap your operator in square brackets. This will force the series matching to be an inner join and not match between them. But the reason why we do this is for cases like this, where you really intend to, add something or divide something or anything to all the input series with no matching occurring. Does that make sense, or any questions about that? Have you seen this coming up yet in any of your use of Wavefront? Or any cases where things didn't match how you expected them to? What I've done for myself is, like I said, Normally it just works, and normally you pretty much don't have to think about it. The doc is pretty good though. Like if you're in a more complicated case and you're not sure exactly what's happening, what I have done is just come into docs, search for series matching, and you'll find a lot of detail here about exactly what's happening. There is a way that you can specify how to do the match. Like say, I know that the point tags are going to differ on either side, so I just want to match by the source and nothing else. And there is even a join capability. This is very similar to what you have in SQL for how you can join tables, data from different tables together. So when you have really tricky cases of combining series together, join can let you go wild and do what you need to do. Depending on time at the end, I have an example of join that I can show you. This is explaining the series matching concept, and I included the link to the documentation that I just showed you here, so that if you want to refer to it yourselves later, you can do so. Okay, standard time functions. These are things like converting counters into rates. These are also functions here that are very useful for doing things like comparing current behavior to what was happening last week, like building ratios of week over week or day over day behavior. For rate, I'm actually going to use an example that came up earlier today from Ken from the Cloud Health team. So this is a extremely common thing. I think one of the most key idioms to learn in Wavefront. And this is the example data that Ken was looking at earlier. When you're graphing this data, you can see that it looks like there's a bunch of lines here that are increasing over time. This is a very common type of data to see in Wavefront. It's called a counter. Wavefront doesn't, there are some systems that really distinguish between these data types, like when you're sending data into the system, you have to tell it this thing is a counter or this thing is a gauge, and you have to be really explicit about it. In Wavefront, you don't have to be explicit. We saw the data format yesterday. It's just this simple data format, send the data in that format, and it'll wind up in the system. So the system doesn't know per se that this is a counter, but it is very common that you will graph data and you'll see it increasing like this, and you'll get to know the pattern that this is a counter. It's very common when you're looking at data like this that you're not so much interested in the total count, but more so interested in how this count is changing. Like this thing is connection queries. I don't know exactly what the data means under the covers, but it's very often with this kind of data that you want to see what's the per second rate of change of this data, and then be able to tell, oh, normally we're doing 100K per second, suddenly we're doing 25K per second. That's probably an issue. Let's look into that. The function for doing that is called rate. What this is doing is taking the difference between each individual data point and dividing by the number of seconds between those data points in order to get to the per second rate of change of this data. I think what was throwing off the user earlier is this at first glance, it does look kind of weird. Like it's pretty spiky. You may wonder, why is it doing that? And I think it just is the way the data is. It is fairly spiky. What is often the case that you will want to do with data like this is combining this function with the aggregation functions that we looked at earlier. Like I'm measuring something like the count of number of requests that are being processed, the count of number of errors, whatever it happens to be. I have a bunch of different things reporting those. I take the rate of them and then add up the total number so that I know across my system what's the total number of things I'm processing, what's the total number of errors that are occurring. Combining some of the other functions that we looked at today, and remembering that you can chain functions together as needed. I don't know whether, Ken, this actually mattered to you, the fact that it was spiky, but we looked at moving functions, so you can smooth things out if you want. If I don't want this data to be as spiky as it is, and I want to see more like the trend of this data, I could try, say, a 10-minute moving average. That smooths it out a little bit. The wider the window to the moving function that I give it, the greater the smoothing effect will be. So if I look at the hourly moving average, then it's definitely not as spiky as it was before, but I can still see that aggregated over an hour, there are definitely higher periods and lower periods.
Yeah, I think the reason, oh, am I even muted? I'm muted.
I can hear you. No, yeah.
Yeah, so the reason why it's spiky is because the total count is in the millions, whereas the actual activity is in the thousands, which is why the line was very straight. But it's also, it's 500 million queries, over a period of time, right? Whereas, so it is spiky, but you can't really see the kind of granularity until you actually look at the rate.
I see. I'm actually not sure if it happens in this case. I'm gonna go to the dashboard to show an example of where these things actually reset. Oh, I think I might have lost my dashboard. I'll go back to it. So in the case of Ken's data that we were just looking at, it actually is literally just increasing all the time. So it's just these numbers that are going up and up. It is not uncommon, and in fact it's expected, that these counters may reset from time to time. And here's a case where it is resetting. The metric we're looking at here actually is an internal metric that's provided by Wavefront. All of the tilde metrics, again, are in things that come with Wavefront. There's a lot of helpful diagnostic information in there, as well as the sample data. This one is not actually sample data. This is real data of how many data points is Cloud Health ingesting into Wavefront over time. And you can see that from time to time it resets. This is presumably when, I guess actually this data is being reported by your proxies. So this must be times when the proxy is restarted. And so this is very common. The counts increase while the system or service or whatever it is that's measuring the data is running. The system may get restarted, the service may get restarted, and the count will drop back to 0, and then it will start counting up again. For that reason, rate ignores those 0 resets. So it's rare that you would ever need it. There is, if you really want the true mathematical derivation, there is a function called deriv, and it will go negative, like where the counter resets, you'll get negative values. Generally speaking, though, that's not what you want. The fact that the system restarted is kind of irrelevant to what you're trying to graph. And so rate ignores those things, and you just see the continuous rate over time as if the data did not even reset. Rate diff is very similar to rate, except it does not do the per second conversion. In fact, if I drill into this data, it might be interesting to see exactly how frequently this is being reported. I think this data gets reported every minute. And by the way, this is a common thing that I do frequently. If if I'm stuck with something, like if a query is not behaving the way I'm expecting it to, I may switch it to a point plot. I might even, you can right click on a line in Wavefront and you can grab elements of it. This can be handy for quickly filtering down to data that you want. I also just mentioned, by the way, you can set up links to other systems here. I'm not sure if Cloud Health uses a logging tool like Splunk or Scalar or something, but if you do and you want to be able to link from your Wavefront into your other tools, external links can do that, and they're driven off the right click. But in this case, I'm going to right click and grab one of the sources, and then I can paste that into my query. Now I'm looking at just one piece of data with the exact points of what I'm seeing. You don't always need this, don't get me wrong, but if something is really confusing you as to why it's behaving the way it is, looking at an individual time series on a point plot where you can see the exact data can be pretty helpful for doing that. And what I can see is this data is reporting every minute. And what that means is that the rate of this data is going to be the difference between the two values. So it's the difference between like 408 odd million minus 405 million divided by 60 seconds. Rate diff is just the direct difference between the data. So it's much larger than the rate usually because it's not dividing by the number of seconds. One thing to note, therefore, so normally this is not an issue. Like, in fact, I've very rarely, if ever, seen any problems with this, but it is worth bearing in mind. The rate information is not perfect knowledge. Like, this data is being reported every minute, and so the rate per second that Wavefront can produce from this data is actually really, it's the average per second rate over that 1 minute interval. We don't actually know, and we have no way of knowing, was this really incrementing by 52K per second? Or did this increment by several million in 1 second and then not do anything for 59 seconds? So usually it doesn't matter. Rate's doing the best it can. It's giving you the most accurate value that it's possible to give you, but worth understanding what's happening. Actually, in the case of your data, Ken, I think it was actually reporting every 2 seconds. So in that case, the rate and rate diff are going to be pretty similar answers, or at least much closer than normal, because rate's only going to be dividing by 2 instead of by 60 in this case. Probably the most common other standard time function aside from rate is lag. So here's an example of how that works. And actually, let me get back to the line chart and zoom out a bit again, since I was so zoomed in there. What we're looking at here is the current 95th percentile, and the percentile here is the aggregation function that's collapsing multiple lines down into one. I can also look at that same data from any point in time. The lag function is the same time window argument as all the other time windows, seconds, minutes, hours. You can specify exactly what you want, but it's shifting this data back, in this case, by an hour. It's then very easy to make ratios of those kind of things. So if the current behavior divided by what was happening an hour ago is fairly consistent with itself, which it is in this case, you're going to expect the values to all come around 1. This can be really useful for alerting. So you can do, I mean, in Wavefront, you can do lots of very powerful intelligent alerting, and hopefully by seeing this query language, you're getting a sense of the possibilities there. But even something like this, which is pretty simple, can be really handy. Just divide the current transactions processed by what was happening 10 minutes ago, half an hour ago, an hour ago, and then alert if that changes, or so maybe it might be nice to say drops. Like if that drops by more than 10%, I want to be alerted to that. Also, being able to lag your data like this, even if you're not doing alerting or you're not trying to build ratios, it can be very handy to just compare what's happening currently to what happened at some point in the past. I may have mentioned this example yesterday, but we've seen with a lot of retailers who have very seasonal events like Black Friday and things like that. They'll want to compare what's happening to our systems today versus the lag of 52W or 1 year to see how we did at the same time last year. One other example that's shown here is the ability to actually manipulate time itself within Wavefront. So there are functions that let you know what hour of the day it is, what day of the week it is. These things can also be used in alerts. Like you can use them to define an alert that says, I want this to fire, but only if it's happening outside of business hours, because during business hours I have my eyes on it anyway, or whatever the use case is. It can also be used in cases like this where you just want to filter data to show you what the data looked like at any given point in time. So this is saying if the hour is 0, which is midnight, in US Central Time, then show what the daily moving average of the rate is at that point in time. If I switch this to a point plot, you can see that there is just one data point every 24 hours, and it happens to be at midnight in Central Time when it's showing that. This is quite, the way that I would often myself think of that kind of query is to align it by a day. So this is something pretty similar. Actually, align it by first on the day. This is going to be a very similar result, except the alignment that you get with align is always based on UTC. So when you're aligning data, you say align to the minute, align to a day, align to a week. All of these numbers and calculations are based off of UTC. So this alignment here is very similar to the Central Time example, except for the time zone. Okay, those are all the functional categories. I do have, well, first of all, let me pause. Is there anything that you've been trying to do with Wavefront that is either is working and you think it's a great example, or you're stuck with and you may want to take a look at? And if not, I did have a few other examples of kind of use of these functions for solving different use cases. And it may even get into a few of the other categories that we didn't look at too much. One is just on the category that we just looked at, the standard time functions. I have seen this kind of data come up with customers quite a bit. This is sort of like the weekly cycle of usage of a system. You can see here that this thing is particularly busy around the middle of the day. It's pretty quiet at weekends, and then it spikes up again. I don't know for sure, but I imagine that this Cloud Health itself might have similar patterns in their data like this, where you have a lot of users logging on and using Cloud Health during the week, maybe less so at weekends. Your data may not be quite as cyclical during the week. Like clearly in this case, the users of this system are fairly concentrated around a particular time zone. That may not be the case for Cloud Health if you have a lot of users in all different parts of the world. But you might still have the weekend data being less than usual. So a common use case that I've seen where those functions that allow you to filter data by time has come up quite a bit is, let's say I want to look at my weekly moving average of this and I want to trend that over time. So that's obviously simple. We looked at that already. I just look at 1 week moving average of the data, and that's it. That's my trend line of how the moving average of this data is. A common thing when you have patterns like this, though, is maybe I don't really care for the weekend data, and maybe I don't even really care for the non-business hours data. Like I want to know what's my weekly average during prime time when I'm busiest. And you can use those time functions and filtering capabilities to do stuff like that. Let's build it up. The first function I'm going to use here is the day of the week. And it looks to me like this is busiest during US Eastern time. So I'm going to pick that as my time zone. I'll just graph this on its own first. So weekday is just going to return 1 through 7 for the days of the week. It looks like Monday is 1, Friday is 5. So if I want to have a filter for something like this, and we didn't look at this function yet. There's a function called between that is just going to give me a Boolean for when my weekday is between Monday and Friday during US Eastern time. So I can see 0 on the weekends, 1 during the week. That may be all I need in a lot of cases, but you can combine these kind of things together with and or not. The system's very flexible that way. So I might actually want to say I only care about it during 9 to 5 Eastern time. So let's do another between, and I'm going to say between 9 and 17 or 5 p.m. So now I don't have that much ones anymore. This is just that little time period during each Monday through Friday that is matching my condition. I'm going to name this one filter. And I'm going to say if, this is very similar to what I showed you with top earlier, actually. I'm going to say if the filter is true, then show me the data at that point in time. And just to show you what that looks like, it's going to show kind of gappy. Like you see how I've got these, I see the data and I see the dotted line showing that there's a gap in data, and then I see the data again. So this is literally just filtered out the data down to the time periods that I care about. These dotted lines, by the way, are what we call the gap threshold. It's really just intended as a visual cue of this data may not be reporting as frequently as you think it is. It defaults to 60 seconds, but you can set this to whatever you need or whatever your expected reporting interval is. And the general idea of it is I'm looking at a chart. I see mostly solid lines, but I do see a time period where there's a bunch of dashed lines. I know that in that time period, there must have been less data being reported than usual. And it kind of pops out at me visually. For this thing, what I wanted originally was the weekly average of my data during the peak time. And so now all I need to do is, same as before, wrap the same moving average function around the data, except I'm wrapping it around the filtered data. And now if I draw all of the lines out in one go, we can see the original data, like what it was really doing. We can see the total weekly average, which includes weekends and non-peak time. and we can see the higher weekly average of the business data, which is pretty cool, I think. Let's see. I mentioned that I had a join example. So, and this came up in a discussion with Cloud Health from earlier in the week. What we're looking at here is some data that is being reported by Telegraph. And you can see that on the Telegraph data, you've got all of the Cloud Health AWS tags are already on there. So at the end of this, you can see like CHT underscore function equals data store. Now, on the Datadog data, where this data is being reported by the Datadog agent, in this case, we do have some tags. There's Kubernetes related tags on this data, but we don't have any of the AWS tags. And that's simply because the Datadog agent is not including those point tags in the data that it's sending. Instead, what's happening under the covers in Datadog is the AWS integration is assigning the tags to the source, and then those tags are being made available to all metrics that source is reporting. That's very similar to the source tag concept in Wavefront, and that's ultimately the approach that Cloud Health is taking to solve the problem in Wavefront. But I did show earlier in the week that if you really wanted to, you can actually join the data together and pull the tags from one place to another. This might have changed since the time that I made the example, but at the time, this source in Datadog, this budget web server, was not being reported by Telegraph yet. So what I did to just work around it, and it shows an example of the metadata functions that we have as well, is I took this data, which was from some source called proxy SQL, or beginning with proxy SQL, that is reporting the Telegraph data already, and I just renamed it to budget web server, etc., just to make these two queries have the same source name. Then what I can do is I can join between them. This is very similar to SQL syntax, and all of the various methods of joining in SQL, like outer joins and so on, are there. In this case, I'm just doing an inner join. So what this is saying is take that first query, the Telegraph one, and name it TS1. Join it with the second query and name it TS2. Match on the source. This can be arbitrary. You don't have to. You can match on multiple things. In this case, matching on the source works in a cheeky way because I explicitly renamed the source to make them match. And I'm saying I want the final metric name of the output to be the Datadog metric name. I want the source to be the Datadog source. I want the environment tag, though, and I want the CHT function tag to come from the Telegraph data. And I want the result to be the Datadog value. In this part, if you need to, you can actually combine them together. So if you were trying to combine two series and you wanted to multiply the values together, you can do whatever you need there. But in this case, all I'm really saying is I want the same Datadog data as I had before, except I want to pull in and add the CHT function tag onto the data, pulling that across from the Telegraph thing. So you may not need this frequently, but it's really powerful when you do need it. I'll confess, even for myself, I do not remember this syntax, the several times that I've needed to do this for some real thing, all I've done is actually worked pretty well. All I've done is I've gone to docs.wavefront.com. I've searched for join. Documentation for this is really, in general, like, to get an understanding of exactly what it's doing. But to actually run the query, I've just grabbed this example, copied it into my query, and just modified it. And that's been pretty quick and easy to do. Another common pattern or use case that I've seen that I thought might be helpful for you to see and perhaps use yourselves if you have situations like this is the ability to predict how long something is going to take. This is a link over to the VMware sandbox, and it's just some period in time where there must have been an issue going on the sandbox where a bunch of data was queuing up on the proxies that were ingesting data, and then those proxies started to drain their queues. And while this draining is going on, you might want to be able to predict how long is it going to take to complete. It might even be the case that you look at it and say the prediction is 12 hours. That's not fast enough, so let's add more capacity to reduce that. I've also seen this technique used quite a bit with things like predicting when volumes are going to run out of space so that you can be alerted a day or a week in advance to go and make sure that you add capacity. The technique is pretty simple. Actually, let me drill into the time. So here's the time period where it's starting to drop off. And here is the prediction. The way this prediction is working, it's dead simple, but I've found that it actually works reasonably well. You take the current data and you divide it by what it was doing a minute ago subtracted itself. So a little complex to do the first time you do it, but if you have this kind of snippet in your back pocket, it's very easy to apply it to all kinds of different data. What I've done in this case is that I'm plotting the time remaining on the right-hand axis, and I have the units is minutes, so this is calculating the number of minutes remaining based on the current trend. So I've set the units to minutes, and I've told it to be dynamic, so it will actually adjust it. The Wavefront will adjust the axis into a kind of a human readable number. So you can see at the beginning the prediction is somewhere a little over 1 hour, and then as the data is trending down, the prediction is trending down to 30 minutes and so on. So pretty useful. We use this internally in Wavefront for this very use case. So this was a case where VMware production cluster was queuing. We want to know how long it's going to take for that issue to be resolved. We also use this for, like I said, disk space alerts. Luckily, we did not run into this case with Cloud Health over the last week. So Cloud Health was adding a bunch of additional data to their Wavefront cluster. They were very good in working with us and informing us what was going on. So the Cloud Health cluster was kept well sized the whole time and did not need to queue up any data. But this kind of event that I'm looking at here can occur if, say, Cloud Health, which is currently ingesting something, I think, like 250K PPS, if it suddenly started sending 1 million PPS, Wavefront would have to upsize the cluster to accommodate that rate. And meanwhile, while that upsize was going on, data points would get queued up at the proxies. And then once the upsize was completed, we'd be monitoring the rate at which the queues are flushing with a technique like this. final example that I'll show is from a Wavefront demo. So yesterday I included the link in the PowerPoint to the demo script. So if you want to play with this for yourselves, you can do so. That link is in the script, or the link to this data is in the script. It is a demo, but it did come up from a real customer use case. It's probably an example of one of the more powerful functions and more powerful moving functions in Wavefront. What we're looking at here is a bunch of network data. So this was data that a customer was collecting from their network switches. It was pretty simple. It was just the number of octets being sent per second by each switch. The customer had some kind of issue in their network around the middle of this chart. And so they had reached out to Wavefront to help with a query to help quickly figure out what had caused the issue. When they reached out to us about this, the network was actually behaving okay, but they didn't at that point have any understanding of what had caused the problem, and they wanted to obviously know that so that they could prevent it from happening again. They got a little bit lucky, the customer, in this case, in that they were able to find a bit of a smoking gun. So one of the network engineers at that company had been looking at just sort of like the core or main switches that they would look at whenever they're troubleshooting their network. They happened across this one that, they knew they had a network issue around the middle of the chart, and this switch was behaving oddly and sending a lot more traffic around the middle of the chart. But they figured if this one switch was behaving oddly, then probably our network as a whole would be fine. So they wanted to find within this haystack of data, so these are all the switches. The one that we just looked at is one of the switches in here. They wanted to know, were there any other switches that looked anything like this? They originally were planning to do this manually. So you've already seen, of course, in Wavefront how you can filter down to a specific switch, and you could have multiple queries, and each query could look at a different switch, and you could manually eyeball them and see if they look similar. Would work, I guess, but would take a really long time. What we were able to do with Wavefront was show the user just how to do that, essentially do that same thing as you would do as a human, manually eyeballing them, but do it automatically. This is a moving function called moving correlation. It's correlating the needle to the haystack, and it's only showing those switches that had a very high correlation to the haystack. This query is showing all functions that we've looked at today in terms of how it works. And it's pretty simple. The correlation function itself is smart, but the query is actually quite straightforward if you break it down. What moving correlation does is, it's a little bit like that top function that I showed earlier. For each input time series, it's going to show whether that data is correlated or not. It returns values between 1 for like the same data, and of course the needle is one of the switches in the haystack, and therefore you can see the needle as 1 itself across the top. It will return -1 for data that is completely inversely correlated. So, while one of the series was spiking up, the other was spiking down at exactly the same way. That would be a -1, or like total opposite correlation. And then 0 is there's no correlation between these at all. Just like I showed with top, we can get what is the correlation at the end of the 4-hour period at the right-hand side of this chart, which turns the data into straight lines. And then again, just like top, we can just wrap that with an if. We want to know if the series has a pretty high correlation, like above 0.75, then show the data and there is no then part. So the other series will just be no data and will be ignored. And so that's how it works. So very powerful and does something really cool, but you can break it down and see exactly how it's all functioning together. I don't know if Cloud Health comes across issues like this. In the customer case, what these switches all turned out to be switches from the same hardware vendor. They had a bunch of different switches from different vendors. These were all one vendor. They all had the same firmware version, and that firmware version needed a patch. And it's possible, that the customer could have had a different way of solving that problem if they had, inventory management system or something that showed them all the different versions of all their switches, but they didn't quite have that in place or something like that in place. And so they told us that not only did Wavefront save them a lot of time in figuring that out, but they didn't know how they would have possibly figured it out at all without Wavefront. And I have had over time, this has been a demo that we've shown for a long time, and I have had several customers reach out at different points remembering this demo and saying, oh, I have some weird issue going on in my data right now. Can we try that same technique and see if we can find it? It's not a flawless technique. It doesn't necessarily always work, but a bunch of times we have reused this to great effect to find similar patterns in the noise, if you will. I think I saw some chat come across. Is there a way to change the precision of a data point? I see. Is this in a table chart or something like that?
Yeah.
Yeah. This actually is, yeah, go ahead, sorry.
Yeah, so I figured it out. I don't know how, how this fixed it, but it did actually give me what I wanted, which was essentially just like raw value, just like a whole number, right? That's what I wanted, what I'm looking for.
Yes.
So the show raw values give me like a whole number figure, right? So like the actual percentage of disk space.
Yes.
Free. Yeah.
This is an area where I would personally like to see some improvements. So there is an option that is what you wanted here on the table chart to just show the raw values, but that option doesn't exist on all charts. So if you were looking at a line chart, for instance, then you see that show raw values option isn't there. And you see when I hover over the legend that it is showing, it maybe doesn't matter as much here compared to a table chart, but you see how here it does have the 53 point ...
Right.
There is a shorthand way of doing it though. It's not very discoverable, but it does work. I am holding shift as I scroll around the legend, and you see now how it is showing me the raw value.
Interesting.
Where this mostly comes up, actually, I guess it's particularly irritating in this case because the number is small anyway. So like, why show me the three precision? But where this mostly comes up is if like I multiply this by 100K to make it into big numbers. You see that the legend is automatically converting those big numbers into something with big M following it. And it's doing this, it's really just trying to save space instead of writing, and sometimes the numbers are even much bigger than this, so it could be like 20 characters potentially to write the axes with the true number. So it always tries to squash it down, but that does then lose some of the precision of the data. And similar, like in this case, you really do have, I guess, let's get really silly, but if I multiply this by random now, this might make it. So you see now this says something like 3.796, but if I hover over it, I can see like the actual raw value. So where I've seen this problem come up more often is not with when the numbers are like less than 100, but where they're really big numbers, Wavefront's squishing them down and and oftentimes that's fine, because oftentimes you really are just looking for the trend, or you're looking for the general sense of it. But there are times when you want to see the actual number. You can do it on the table chart, and you can hold shift to see it. But hopefully these be things that will get improved over time in a more general way.
Thanks.
Any other questions? Was this helpful?
There's a lot to take in.
Yeah, for sure. I think the purpose of this session is to go deep into the query language. I think as a new user, a lot of times all you really need to do is just graph the data, and all you need for that is that chart builder. And there can be a lot of value in just seeing your data and then looking at it over an 8-day view and see what's happened over the last week. That's really, really simple to do. And then you can just work from there. And if you need to do, if you have a more complex use case, then you can start bringing more of the query language to play and learn it over time. And you can obviously see from some of the stuff that Ken's doing here that plenty of the users at Cloud Health are already doing that and using the language very effectively. All right, so we will leave it there for today. There are some exercises, just like yesterday, that I'm going to paste into the channel. And let us know if you have any questions about those in the channel. In this case, it's a little like query language exercise. So later today, I will paste kind of my version of the answers. There could actually be potentially different ways to solve the problem. So your answers may not match mine exactly, but I'll show you what I did. And I will also paste the slides and the recording when it's ready.
Awesome, thank you.
So thanks everybody. Tomorrow's session is more kind of user orientated, I would say. Like today is really the kind of deep dive one. Tomorrow is more focused around just using and interacting with the system, how you work with dashboards, build dashboards, edit them, and things of that nature. So looking forward to it.
Thanks. Bye-bye.
Thank you. Goodbye. See you tomorrow.
For more information, detailed videos, and blogs about all Aria Suite products, please visit apps-cloudmanagement.techzone.vmware.com or simply scan the QR code to learn more.